In our previous two videos of Surds, we have seen how Surds calculation work, especially multiplication, division, addition and simplification. And in our second video, we have seen when we have brackets with Surds, how we can simplify them. Today, we are going to do the last and the most important topic of Surds, which is rationalizing denominator. And for this is must know and use the things that you have learned in video 1, video 2. So first of all, I will request you to watch those two videos so that you don't face any problems here. Now, there are many types of rationalizing here. We are going to do all the types, and when we are done with all the types, you will be rationalizing any denominator just like that. It's very easy. So let's start with type 1. The very basic question. Let's say we have a surd 1 divided by square root of 5. Now, this square root of 5 is a surd, and we know that surds are irrationalized. So when we want to rationalize it, the target is to remove the square root. And how can you remove the square root? We are going to apply one of our knowledge from the first video, which is if we multiply the same surd twice, we get the integer. Like this, we have square root of 7 multiplied by square root of 7, the same surds are there and we get the integer there. Just like that, if we multiply square root of 3 with another square root of 3, we are going to get the integer 3. And it's also true for algebraic terms. Let's say square root of a and square root of a, we get a. We are going to use this phenomena here to rationalize our denominator. How do you do that? Let's say this one, we know that if we want to remove the square root from 5, we can multiply with another square root of 5. But when we do this, you must keep that in mind that these two fractions must be equal. So if we only multiply the denominator, it's not going to be equal, right? So what we're going to do, we are also going to multiply the numerator with the same thing. So we basically multiplied the numerator and the denominator with square root of 5. What this does is we get 1 multiplied by square root of 5, which is square root of 5, and as our numerator, and when square root of 5 is multiplied by another square root of 5, we know that it's going to get the integer only. So this is how we just rationalized our square root of 5, an irrational number, to a rational number 5. Now, sometimes you might have a different kind of numerator, the type 2. Let's say you have something else other than 1 as a numerator. For example, let's say we have 7 divided by square root of 3. So how do you do it? It's the same thing. We do not focus on the numerator, you only focus on the denominator. So we have square root of 3. We know that another square root of 3, if we multiply with this, the previous denominator, it's going to turn into a rational number. So what happens? If we multiply the denominator, we must multiply the numerator too. So ultimately 7 multiplied by square root of 3, we know that it's going to be 7 square root of 3. And when square root of 3 and square root of 3 is multiplied, we get the integer 3. See, again, applying the same rule, we can do this and we can simplify and rationalize our denominator. Now, let's see another type, type 3. So, in type 3, sometimes you may need to do a little bit of simplification after your rationalizing is done. For example, let's say we have 24 divide square root of 6. First of all, let's do our rationalizing. We know that square root of 6 must be multiplied by another square root of 6. So we have to multiply the numerator too. So when you do that, you simply got 24 square root of 6. And at the bottom, square root of 6 and square root of 6 is going to give us the integer 6. But we are not done yet. Now that there is a scope for simplification, we can divide 24 by 6. So ultimately, this 6 is going to divide this 24 and we are going to get 4. So we are going to get an answer of 4 square root of 6. So these are the very basic versions. You can go one by one and we are going to increase the difficulty level. Let's see some other maths. Sometimes you can have an integer in your denominator with your surd. Now let's see how we can rationalize it. Let's say we have 3 divide 2 square root of 7. Now, how do you rationalize it? Now you might think that you need to multiply the denominator with 2 square root of 7. But we don't need to do that because this 2 is an integer, it's already rationalized. We don't need to multiply with a 2. We just need another square root of 7. How? Let's say we have 2 square root of 7 here. We need to rationalize this square root of 7. So we are just going to multiply with square root of 7. Now we multiplied the denominator, we must multiply by the numerator with the same thing. So we are going to have 3 square root of 7 as our numerator, and 2 will be there. Square root of 7 will give us the integer 7. Now we have one step to do, one more step here, because we have two integers there, so we can just multiply them. Finally, we're going to have 3 square root of 7, and 2 multiplied by 7 is 14. So this is how you can approach when you have an integer already in your denominator. Now let's see another type. Let's say in our type 5, we have a different kind of question. Let's say 13 divided by square root of 48. Now, why am I calling it different? Because we can obviously approach in the same way that we did for the other maths, but when we have the chance to simplify, we are always going to simplify, and it's going to make our life easy, right? So what can we do? We have 13 there. We do not multiply with the square root of 48 directly. Instead, we break 48 and we write square root of 16 multiplied by 3. Why? Because we know that 16 is a square number and we can break it down. So we will have less hassle. First of all, let's square root 16. We are going to get 4. We cannot square root 3. So we are going to have 4 square root of 3. Just like that. This now the math just looks like the previous one. What are we going to do? Let's write it on this side. We are going to approach with the same thing. We have 4 square root of 3. We know that we need only to multiply with square root of 3, not the 4, because it's already an integer. We multiplied the denominator, so we also multiplied the numerator. So finally, we're going to have 13 square root of 3. Now at the bottom, we already have 4, and square root of 3 and square root of 3 is going to give us 3. So finally, we have 13 square root of 3 divided by 12. So this is how, when we have an opportunity to simplify, we are first going to simplify to make our life easy and to make the maths easy. Now, let's solve an exam style question from whatever we have seen so far. This is the type of question you are mainly going to get in your exam, where they are not going to ask you to simplify or rationalize the denominator directly, but the question will say, we have this thing, express this thing as this thing, where you will be final answer must contain integers. So we have a question here. We have square root of 45 plus 20 divided by square root of 5, and we have to show it as a square root of b, where a and b are integers. Now we know already how to simplify this one from our first video, and today we learned how to simplify this one. Now let's combine them and see how we can solve this question. First of all, let's look at 45. We can write 45 as 9 multiplied by 5, and the square root obviously be there. And 20 divided by square root of 5, we know how to rationalize the denominator. We already have a square root of 5, so we are going to multiply the denominator with another square root of 5. And when we do that, we must also multiply the numerator with square root of 5. Now let's see how it approaches. So 9 is a square number, so you can square root it, and we are going to get 3. And 5 cannot be square rooted, so we only get square root of 5, the same thing back, plus. Now we have 20 square root of 5 as our denominator, and square root of 5 multiplied by square root of 5. Again, same surds. When we multiply same surds, we get the integer, so we get 5. Now look at the question here. Look at the answer we have done so far. This 20 can be divided by this 5, and we actually cannot do anything here. So 3 square root of 5 remains as it is, and we can divide 20 by 5, which gives us 4. So 4 square root of 5. Finally, we have 3 square root of 5 added to 4 square root of 5. In total, it's going to give us 7 square root of 5. Can you match it now? We have our a square root of b format. So what's the value of a here? A is 7 and b is square root of 5. So this is how we can also approach our exam questions. But questions are getting harder, and we are also going to the harder maths. Let's go to the next step. Now let's say you have multiple terms in your numerator, and you have a surd or a irrational number in your denominator. How do we approach? First of all, we follow the same rule. We do not look at the numerator, we look at the denominator only, and we have only one single term. First thing we are going to do is to look at if we can simplify it. Can we simplify 18? Yes. Can we get a square number there? Yes, we can. How? We can get 9 multiplied by 2 square root, and 9 is a square number, so we can simplify it. So we did not do anything yet at the bottom, so let's keep the numerator as it is. Now next step, again we did not do anything, so the numerator stays same. In the denominator, 9 is simplified as 3 when square rooted. So we get this thing. Now let's move on to the next step. We have 3 square root of 2. So when we want to rationalize it, we must multiply with it square root of 2, not 3, square root of 2 only. So what do we have at the bottom? We have 3 square root of 2, that is multiplied with another square root of 2 to rationalize it. And at the top, we have square root of 7 plus 2. Now remember that we are multiplying this the whole thing of the numerator by square root of 2. So you must use a bracket. If you don't use a bracket, the square root of 2 will be seen as only multiplied with these two, but that's not true. We are multiplying both the terms in the numerator by the square root of 2 that we have taken extra in the denominator. So we must use a bracket. Now let's do it. We have seen how brackets are expanded in Surds in our second video. Let's multiply them. Square root of 2 multiplied by square root of 7 is going to give us square root of 14 plus 2 is an integer going to get multiplied with the surd, so we are simply going to get 2 square root of 2. And at the bottom, we know that this is 3, an integer stays like that. Square root of 2 multiplied by square root of 2 is going to give us just 2. So finally, we are going to have square root of 14 plus 2 square root of 2 and divided by 3 multiplied by 2, which gives us 6. And you cannot approach anymore in this math. So this is how, when you have multiple terms in your numerator, you can approach and finally simplify it. Now what if your denominator has multiple terms, not the numerator? Just like this question, 4 divided by 5 plus square root of 3. So we have two terms, one is 5, one is square root of 3. No, now you know that it's not the same as having 5 square root of 3, because 5 and square root of 3 not multiplied. We have them as addition in there. So we have two different terms. How do we approach? Now we cannot go with the approach that we did in our previous math, because let me show you why. Let's say we have 5 plus square root of 3 and you decided that I'm going to multiply with, let's say, square root of 3. So what's going to happen? You are going to get 5 square root of 3 and then plus square root of 3, and square root of 3 is going to give you 3. See, even after when you multiply with square root of 3, you are still left with one surd, square root of 3, right? So only multiplying with the surd here is not going to work. So we need a different approach. What kind of approach? We are going to multiply the denominator with the same terms we have here, but with a different sign. For example, we have 5 plus square root of 3. We are going to multiply with 5 minus square root of 3, nothing else. We are just going to multiply the terms in our denominator with the same thing, but with a different sign. The plus becomes minus. If we had the minus here, we would have made it a plus. That's the same thing. Let's see what happens. Now we multiplied at the bottom, so we need to multiply at the top too. So with this one, the new one, 5 minus square root of 3. Let's keep it like this. Now let's see what happens. At the top, we know that we can multiply according to our surd multiplication formula, which is 4 multiplied by 5 gives us 20. 4 multiplied by square root of 3 is going to give us 4 square root of 3. At the bottom, we know now we have to dissolve the brackets. First of all, we take 5, multiply both of them in the second one, and then we take square root of 3, multiply both of them in the second one. Let's start with 5. So 5 multiplied by 5 is 25. 5 multiplied by minus square root of 3 minus 5 square root of 3. The integer is always written at the in front of the surd. Now we are done with 5. Let's move on to plus square root of 3. So plus square root of 3 multiplied by 5. As I said, the integer is written at the front. So 5 square root of 3, let's expand it. Now the second one, plus and minus is going to give us minus square root of 3 multiplied by square root of 3. We know that it's going to be 3. So ultimately, what did we get? What we got is the top one stays like that, 20 minus 4 square root of 3. At the bottom, we have minus 5 square root of 3 and plus 5 square root of 3. So basically minus x plus x. So both of them are done. We don't need any one of them. So we have 25 minus 3, which is going to give us 22. Okay. We are done, but we can simplify it further. So when we can simplify, we will simplify. For example, we can take 2 as the common number in our numerator. So we are going to have 10. 20 divided by 2 is 10 minus 4 divided by 2 is 2, so 2 square root of 3, and at the bottom we have 22. Now this 2 can simplify this 22, we are going to have 11, so final answer is 10 minus 2 square root of 3 divided by 11. So this is how, when you have multiple terms in your denominator, you are just not going to multiply with that only surd, you are going to multiply with the terms again but with a different sign, and then it becomes very easy. Just like that, you can follow it and solve it. Sometimes we can have multiple terms in our numerator and also in our denominator. It may look a little bit difficult, but it's not. We just need to follow our method and we can easily solve it. Let's see. First of all, what we are going to do is to look for simplification. Can we write 80 in a way that gives us a square number? We can, right? 16 multiplied by 5. So 16 multiplied by 5, that's our 80, and that's the square root there, and plus 5. We are done with the numerator here. Now at the lower one, 45, we can also use a square number 9 to simplify it, and then square root, then minus 2. Okay, now what we are going to get there, 16 will become 4 when square rooted, and we will have 4 square root of 5 plus 5, and at the bottom 9 square root of 9 will become 3, the square root of 5 will be there, and the remaining thing is minus 2. So that's it. Now that we have the simplified term, now let's see how to rationalize the denominator here, and we are going to approach the same thing. We have two terms there with negative in there, so we cannot just multiply the square root of 5. We have to follow the type 8 approach. Let's ignore the numerator. Now let's work on the denominator first. We have 3 square root of 5 multiplied negative 2. So we have to multiply with the same terms but with a different sign. This negative is going to be positive, and we are going to use the same terms, 3 square root of 5 plus 2 instead of minus. Now this is the extra, so we must put it in the numerator too. In the numerator we already have 4 square root of 5, and it is added with 5, and we have taken a new thing at the denominator, so we are going to apply it in our numerator too. So 3 square root of 5 plus 2. Now let's just follow our method and dissolve the brackets. First of all, let's take this term and multiply all the terms inside the second one. 4 multiplied by 3, let's multiply the integers first. 4 multiplied by 3 is 12. Square root of 5 multiplied by square root of 5 is simply 5. We are done with this one. Then plus 2 multiplied by 4, the integers there, 2 multiplied by 4 is 8, and we don't have any surd there, so square root of 5 remains. Now we are done with 4 square root of 5. Let's move on to plus 5. So 5 multiplied by 3 is 15, and only the square root of 5 is there. And 5 multiplied by plus 2, so it's just plus 10. We are done with the numerator. Now let's move on to the denominator. So let's take this first one and multiply with this one. Integer multiplied by integer, so 3 multiplied by 3 gives us 9, and square root of 5 multiplied by square root of 5 gives us the integer 5. Now let's move on to the second one. Plus and plus is plus. 2 multiplied by 3 is 6, and you only have square root of 5 there. Okay, now let's move on to minus 2. Minus and plus will give us minus. 2 multiplied by 3, the integers give us 6, and then square root of 5. And minus is there minus, so 2 multiplied by 2, it gives us 4. So now we are done expanding the brackets. Now let's see what we actually have. 12 multiplied by 5, which is 60. 8 square root of 5 and 15 square root of 5. In total we have 23 square root of 5. And then we have plus 10. Okay, now let's see what we have in our denominator. 9 multiplied by 5 is 45. Let's look at the square root of 5s. We have plus 6 square root of 5 and negative 6 square root of 5. So ultimately we don't have any square root of 5. So we don't need any one of them. We have the negative 4 only. So finally, what do we have is 60 plus 10, which is 70, plus 23 square root of 5. We cannot change anything or simplify it here. Divide, and our denominator we have 45 minus 4, which is simply 41. So see, just like that, our denominator is now free of irrational number. And when we have multiple terms in our numerator and our denominator, we can follow the same method, same approach, same calculation model, and we can solve any one of them. I think that You are not going to face any more problems in rationalizing the denominators. We have done all the types. You see any of the math and you follow the type and you will solve any one of them so easily.